Hi student, let's try to understand a problem student. That is a very important problem actually. So what the problem student? Question number 11 of the chemical kinetics student. The question is saying the following result have been obtained during the kinetic study of the reaction 2A plus B gives C and D. These are the experiment student. Concentration of A in mole per liter, concentration of B in mole per liter, and initial rate of reaction, initial rate of formation of D. The coefficient is 1 is there, D in mole per liter. So this is whatever. So what we can do is to determine the rate law and the rate constant of the reaction. That is what they are asking in this question. So dear student, let the rate of reaction is as, how you can write student rate of reaction? So rate is equal to what is there student? K. For A power we don't know the order student, so we can write P, and B power we don't know the order, so we are writing Q, right? So this is the general equation student. From you can have student, this is, suppose it is the R1, this is R2, R3, and this is R4, because here the experiment number they have given student. So what we are talking about for the P, or for even you can go for the student from what we can go student from 4 to 1. We are dividing equation 4 to 1. Till now I didn't made the equation, but here you see why I am taking 4 to 1 dear student, because here 1 is there na, 0.1 and 0.1 they can be easily get cancelled out. That is why I am taking this one. So we can get from here 4 to 1, we can get the value of what? We can get the value of student A, because P will be cancelled out, and the second time we can take the 3 and 2, so we can divide these two, so we'll get the value of what? This one, Q value. And here you see student, we have to divide the larger value with a smaller, so 10 power minus 2 is there, this is bigger and this is smaller. Similarly we will divide the 3 equation by 2, because this is the bigger value than the smaller. So this is what the concept student, right? So from 4 and 4, so R4 by R1 equal to, K is there student, K is the constant. Now A concentration in case of 4, this one 0.4, power what will be there student? P, and here concentration 0.1, power is P. Now you go for the B concentration, so this is 0.1 power Q, and here is also 0.1 power Q. So this is there equal to rate what they have given student here, 2.40 into 10 power minus 2 divided by 6.0 into 10 power minus 3. So dear student, if you see, this will be cancelled out, this is cancelled out. So if you divide this one, so it will give 4 power P, 4 power P equal to, if you solve this one student, so what will come? 24. So 4 power, it is going to be what student? 1, 4 power 1. So P is equal to 1 student, because 6 4 is 24, P is equal to. So what we can do? So A is no reaction with respect to, better you write the statement, reaction with respect to A is what student? First order dear student. Okay, now come for the second one. Which one is the bigger one student? 10 power minus 1 is bigger than 10 power. So now for what? for student Q. Okay, equation 3 divided by equation 2, right? 3 divided by 2 student. So R3 by R2 is equal to K. This is K, and A concentration in case of the R3 student, how much is there student? This one 0.3 power P, and R2 in the constant 0.3 power P. Now in case of B student, how much is 0.4 student? 0.4 power Q, and that is this one value 0.2 power Q. Up rate we are writing 2.88 into 10 power minus 1, then 7.2 into 10 power minus 2. Dear student, if you see this one, this value will be cancelled out completely and kk cancel out, and this one you are dividing, so 2 power q is equal to this will come how much student? 4 times 4. So 2 power q is equal to 2 power 2. So that is exponent get compared. So q is equal to what is that is 2. So what we can write student, reaction with respect to B is what order student? Is second order student. Is second order. This is what the point student. So how can we write the rate student? So rate is equal to K, A power going to be 1 and B power going to be 2 students. So this is what the first part of the question we have solved, because here determine the rate law and the rate constant of the reaction. Rate constant very simple student. From the first experiment, what we can do student, from the first experiment, R1 is equal to K, A power 1, B power 2. So R1 they have given student first experiment 6 into 10 power minus 3. 6.0 into 10 power minus 3 equal to K. A concentration you can see student, A concentration 0.1, B concentration 0.1. So here is 0.1 power 1 and here is student 0.1 power 2. So 6 multiplied by 10 power minus 3 is equal to K. 0.1 multiplied by 0.1 multiplied by 0.1. So 6 into 10 power minus 3 is equal to K into 10 power minus 3. This and this cancel out. So K is equal to 6 student. K is equal to 6. What the unit student? Unit will be same student. Whatever the unit they have given here. So what is? Mole per liter per minute. Right student? Unit if you are writing, the same unit is supposed to be student. Or we have to put the values student, because it will be the mole minus 2 liter square minute inverse student. How we are taking this one? Because here the unit is how much is there student? Mole per liter. They have given in the equation here. This is what? Mole per liter per minute. Mole per liter per minute, dear student, is equal to K. And here is what is there student? Mole per liter power 3. Because here is 1 and this is. So what will be the K is equal to mole per liter per minute divided by mole per liter power 3. So 1 is going to be cancel out. So what is K is equal to mole minus 2 and that is liter square minute inverse student. So this is our required answer, dear student. Thank you very much for watching student.